All right, and welcome back to unit number 4, conservation of energy. This video is still on lesson number 1 pertaining to work, and we're going to be going over example problem number 3. Now, this example problem is, I think, quite straightforward, and I think that most of you now have some skills at reading graphs, so it should go over fairly easily. So in this first example, we have a changing force acting on an object over a displacement of 9 centimeters. We're supposed to calculate the work done by this force. All right, so where are we going to get going on this here? I should have written on here that this distance is 9 centimeters. Okay. Well, if we are dealing with work is equal to force times distance. We know that. Force times distance. And this graph has force against distance. So if we multiply force by distance, this is going to be like length times width, or base times height. We're essentially going to be calculating the area under this line. All right, well, with that in mind, how can we figure out geometrically the area under this graph? Well, actually, I'm going to keep green. That's great. We can split this up into two easily solvable shapes. We have a triangle here and a rectangle here. So now we can solve, we can solve the triangle here. We can solve the rectangle here. Okay, now there are some markings along this that I didn't really record here. I believe this is about 2 times 10 to the 3, and up here we have maybe 6.5 times 10 to the 3. These are newtons, so we can use those values. Yeah, let's do a little solving. So our work here is going to be the area under the graph, so I'm going to say we're going to have 1 base times height divided by 2. That's our triangle. And we're going to add just a rectangle, length times width. Okay, well, on our triangle, we are going to have a base value of 9 centimeters. I got to convert that into meters, so it's going to be 0.09 meters. That's going to be multiplied by the height of this thing is going to be 4.5 times 10 to the 3 newtons. There we go. I'll put that in brackets too. Why not? Whole thing's divided by 2. And then let's do our rectangle. Base is still 9 centimeters, so 0.09 meters. And the height of that little rectangle is just 2 times 10 to the 3 newtons. All right, plug those all in our calculator, and this question's literally done. Okay, pluggity plug works out to 383 joules. Okay, so there we go. A little bit of graph interpretation, a little bit of knowing how to interpret and how to solve area under the graph. That's all for example number 3.